Welcome everybody to another video lesson. We are starting our unit on probability and statistics today. We're going to start off with random sampling, and after this video we will be able to tell the difference between different types of surveys, experiments, and observational studies, and then we're going to make some inferences about the information that we gathered throughout those studies. So let's hop into the concepts, and first thing we need to do is take a look at some vocabulary words. Now, first thing, we need to know the difference between a parameter and a statistic. Okay, a parameter, think P, right? Parameter, P for parameter, is talking about your entire population. All right, so that is some sort of descriptive measure that is referring to the entire population. So an example here is our population size. You can see down here, if you have, say, a population mean, then that is referring to, again, the entire population. Now, in these studies, we are going to be taking a sample of the population, so some smaller group within the population, and we're going to calculate a statistic. Okay, so S for statistic and S for sample. So a statistic is a measure that we are calculating using the data that we gather from a specific type of study. All right. So after we gather some information, we can calculate a statistic where a parameter, again, is referring to the entire population. All right, now one thing that is very important to be able to realize within these studies is when we have bias. Now, bias is going to be some misrepresentation of a certain population. So if I am a restaurant owner and I want to see if people like my food, and I say, okay, throughout the week, anybody who comes in more than twice or more than once, we're going to give them this survey and ask them how much they like our food. Well, that's going to have some bias in there, right? Because people who come back to a restaurant generally like the food, right? So, of course, they're going to give you some positive reviews there. So that's not going to give you the best representation of all of your customers. That's just going to be the people who already really, really like your food and have to come back multiple times throughout the week. So that is bias there. Now, to avoid bias, what we can do is make sure we are taking a random sample of our population. So if you have a population of customers, again, for your restaurant, a way to avoid having bias is to take a random sample. So you could say, well, throughout the week, every night, I'm going to randomly choose 5 customers and give them this survey and see how much they like their meal at the end of the meal. And that's going to give me some good information about whether or not we're doing well as a restaurant or not. Again, not just picking people who like my restaurant, but picking people who come in throughout the week. All right, so our different types of studies. We have surveys, experiments, and observational studies. Now, a survey, just like we were talking about with our restaurant, that's when you give people, maybe like a little quiz, or you guys have taken a survey before, and you're just gathering really opinions, and that is the data that you're collecting when you give out these surveys. So if you have 200 people and you select 50 of them and give them a survey, you might ask them, do you like the food? And they can say yes or no. Again, that's an opinion, so you're gathering opinions, and that is the data that you're going to use to make your inferences. Okay? An example of that is if you've ever had this cafeteria food, you may have taken a survey that was sent out to determine whether or not the students actually like that food or not. An experiment is when we have 2 groups of a sample. All right, we have an experimental group and we have a control group. Now, the experimental group is the group that's actually being studied. That is the group who is having some sort of change and being affected by the study, while the control group is actually not going through any change at all. So if you were a medical company and you were trying to determine the effects of some sort of diet pill, some weight loss pill, you might take a certain 100 people, right, and give 50 of them the weight loss pill, and then you might give the other 50 just a little sugar tablet. So they're not actually getting the pill, they're getting what we would call a placebo. And you might take a look at the different effects that the experimental group has compared to the control group, who's really not actually being affected by your study. An observational study is our last one. That's when members of our sample are observed or measured really without being affected by the study at all. Okay, so it's almost like you're stepping back, you're looking at what they're doing, you're gathering information. They're really They don't even have to know that you're there gathering information about them, okay? So our 4 steps of a study, a statistical study. First thing we want to do is identify the study's objective. Now, it's important that we do this first because this is going to help us identify any bias. If I know that I'm going for a certain outcome, I need to know how to not provoke that outcome throughout my study. Okay, after we've done that, we can choose a sample and collect our data. So you want to choose the best type of study for what you're looking for. And then we can organize the data and calculate some sample statistics. And then from those statistical values, we can make inferences about the entire population. So again, if I have a group of 200 people and I survey 50 of them, I'm going to make an inference or draw a conclusion based off of just those 50 people's responses. I'm going to make that conclusion about the entire population. Okay, so that's our last step for a study. All right, let's get into these examples. First thing we're going to do is classify some studies. First one here, scientists studied the behavior of one group of dogs, giving a new heartworm treatment, and another group of dogs given a false treatment. Again, a placebo is what we would call that false treatment, that sugar tablet, or something that's not really going to affect that control group. Now, we know anytime we have 2 groups within our sample, that is going to be an experiment, right? So the sample are dogs given the heartworm medication, and the population is going to be all dogs. All right, so their yearbook committee conducts a study to determine whether students would prefer to have a print yearbook or both print and digital yearbooks. So again, they're gathering information, they're gathering opinions, which means that we're conducting a survey. Now, our sample are students participating in the survey, while we're going to make inferences about the entire student body. So everyone at that school, just based off of students who participated in the survey. All right, now let's choose the best study type for both of these situations. First one here, a pet chain wants to know whether customers would pay a small annual fee to participate in a rewards program. They randomly sampled 200 customers for their study. Now, they are asking their customers about their opinion of this rewards program. So what they are doing is conducting a survey. And the data that they are going to obtain is going to be the opinions given by members of that sample population. Okay, a research company wants to study smokers and non-smokers to determine whether 10 years of smoking affects lung capacity. So again, here we would go find 50 smokers, 50 people who don't smoke, and you're going to say, just go about your lives. Don't do anything different. If you want to smoke, smoke. If you don't want to smoke, don't smoke. And then at the end, we're going to measure your lung capacity. So these people aren't actually being affected by this study, right? They're not having to take a pill or do anything different. They're just going about their lives, which means this is an observational study. Okay, let's make some inferences now. We have a sample group of 685 students at a high school. They are going to be surveyed and asked to name the type of technology they would most like to use for learning a foreign language. Based on the results of the survey, what is the most reasonable inference about the number of students who would like to use a laptop during to learn a foreign language? So here we have our survey results. So the first thing we need to do is figure out how many people actually participated in the survey. We need to find our sample size. Again, this whole population is 684 students. How many people did we choose for the sample? Or how many people participated in this survey? So what we can do here is just take each one of our categories and add them all up. So we had 20 students who chose smartphone, 25 with a tablet, 15 responded saying they would like to use a laptop, and another 20 that chose a desktop computer. So that was a total of 80 students within this survey. Now we need to calculate what's called our sample proportion, which is just whatever my chosen characteristic is, the number of people who chose a laptop in this instance, okay, divided by our total sample size of 80 students. So 15 divided by 80, it's just that ratio there of the characteristic that we're looking at over the total population size. Or not the total population size, sorry, but the total sample size. And then from there, we can make our inference and say, well, my sample proportion multiplied by my total population is going to be about 128. So we can make the inference that 128 students at that high school of 684 students would like to use a laptop to learn a foreign language. Okay, so just based off of 80 students, I'm making an inference about the total population of our 684 students. All right, last example here, identifying some bias. A high school wants to redesign a mascot used for each of its sports teams. An administrator surveys a random sample of the basketball team to see whether the school's athletes want the same mascot, okay, with a new design or a different mascot entirely, and finds that 10 of the 20 respondents want the same mascot. From this, the administrator determines that approximately 1,532 of the high school's 3,064 athletes want the same mascot. Identify and explain any bias that might affect the validity of this administrator's inference. So, since this person chose to survey only the basketball team, right? But they're making an inference about all the athletes in the school, right? So our basketball team is just a specific group of our athletes, and therefore they're not going to accurately represent all of the athlete population, right? The athlete population is what we're looking for. So from that, we can see that the inference made might be affected by the bias that was in this survey, which we want to avoid when we are doing our statistical surveys and studies. All right, guys, that is it for this video. Good luck with your practice.